Good day once again, everybody. So we are looking at question 9 of this Eastern Cape November 2023 exam. So please, if you haven't subscribed, make sure that you're part of the family, right? So we're going to look at question number 9. We've already done questions 1 to 8. If you like, please go ahead and go and have a look at those before you start with this one. Right, but now we look at probability. So they say to us, for any two events, A and B, it is given that the probability of A is 0.35, the probability of A or B is 0.61, and they say determine the probability of B. Now they are giving us a couple of conditions. They say if A and B are mutually exclusive. Now remember, when we say events are mutually exclusive, right, these are two events that are not going to meet, right? So what does that mean? It means the probability of A and B, there's no intersection. So the probability of A and B is equal to 0. Okay, so please keep that in mind. So now, what we normally do for these questions, we use the general principle of probability. And what does it say? It says the probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. Right, now note, in this case we said the probability of A and B for mutual exclusivity, it has to be equal to 0. Probability of A, they told us, is 0.35. We are looking for the probability of B, right? Minus the probability of A or B is 0.61. So that's 0.61. Okay, so which means we're going to have 0.35 minus 0.61. Okay, that gives us negative 0.26, but if we take it to the other side, it means that the probability of B will be 0.26. Right, so that's how we'll get the probability of the probability of B if it is said to be mutually exclusive. Right, now let's go on to the next question. So they say to us, if A and B are independent. Now note, for independent events, we say that the probability of A and B, it will be equal to the probability of A multiplied by the probability of B. Right, I don't have the time to explain that part. Please go and look at our videos on probability so that you can understand that. So which means the probability of A and B will be the product of the probability of A times the probability of B. So let's write down our general principle again. And what does it say? Probability of A and B equal to probability of A plus the probability of B minus the probability of A or B. Right, let's go for it. So this is going to be probability of A times the probability of B, right? Because the events are said to be independent. That's A plus probability of B minus the probability of A or B. Now let's try and find out in this case. So probability of A, that's 0.35 times the probability of B. Probability of A, 0.35. Probability of B, that's what we are looking for, minus probability of A or B, which is 0.61. All right, now let's try and isolate everything that has probability of B. Okay, so one probability of B minus 0.35, or in this case, let me take probability of B to the other side. I'll have 0.35 probability of B minus 1 probability of B. So that will be minus 0.65 times the probability of B. Okay, so note in this case, this is the same as saying 0.35x minus x. So note in this case that what we have is, if we took out x as a common factor, you'll have 0.35 minus 1, right? And that's how we were able to get the negative 0.65 probability of B. And then this has numbers in it, 0.35 minus 0.61. Okay, this is going to give us a negative, okay, minus 0.26. I'd forgotten the number that we got there. Right, and apologies guys, I'm just going to write over those words. So I'm dividing by negative 0.65, but what I do on the left, I do on the right. Okay, so the probability of B in this case, that will be divided by negative 0.65. And I get that to be equal to 0.4. Right, so please remember those conditions that were given, that anytime that they say events are independent, it means that the probability of A and B is equal to the probability of A times the probability of B. But if they talk about mutual exclusivity, it simply means that the probability of A and B are simply equal to 0. Right, and then let's go to the next question. They give us a contingency table. One of the easiest ways to ask probability is definitely this guy here. So they say a cell phone distribution company investigated the number of defective phones that they obtained from 2 suppliers, Axis Phones and Direct Phones. I assume this must be some brand that we know. They didn't want to use brand names, hey? So they recorded their findings in a contingency table. Defective, okay? A 58, and you've got the rest of the table. Now, what I want you guys to please appreciate is that going down, right, there, 384 phones, that's the total number of Axis phones. And here you've got the total number of, so this would give you the total of direct phones, right? But here you are getting the total number of defective phones, and here not defective phones. Okay, so whether you're going to take the total horizontally or whether you're going to take it vertically, you still arrive at the total number over there, which is 600. So they say to us, determine the values of A, B, and C. All right, now let's start here. So 384. Okay, let's see. Can I start with A? Nah, that's fine. So let's start with B. Okay, so it means B plus 514 is equal to 600. So what would be the value of B? So that would be 600 minus 514. So that would be 86. So this value is 86. Okay. What would be the value of A? This value plus A. So 58 plus A will give us 86. So So what's the value of A? That's 86 minus 58, and that would give us 28. So that's 28. And what is our C value? So we either could have found C by saying 384 plus C is equal to 600, or we can say 28 plus 188. Okay, that will give us the value of C even still. Right, so let's use this one. So C will be 600 minus 384. So that gives us 216. And we can check. If we took again 188 plus 28, we should get the same value, 216. So that's 216. All right, I hope that we got that part. So we've got the values of A, B, and C respectively. Now they say to us, what is the probability, calculate rather, the probability that a cell phone chosen at random is supplied by direct phones. Right, how many phones is direct supplying? It's a total of 216 out of the 600. So the probability of finding a direct phone is 216 divided by 600. Okay, 216. So that will be 0.36. Right, now they say calculate the probability that a cell phone chosen at random is not defective, or it is from axis and so a cell phone chosen at random is not defective, so not defective, or it is from axis phones and defective. Okay, right, so in this case we are looking at not defective. Right, so the total number of phones that were not defective is 514, but they are not just looking for not defective, they're also looking at the defective axis phones, right? So it's either not defective or it is from axis. Now remember, of the 540, it also includes phones that are from axis. Okay? Right. So I want the ones that are axis and defective. Okay? So where's axis and defective? Right, so that's the 58 over there. Okay, right, so in this case that are not defective or from axis and defective. Okay, so I am going to add that probability. So that is the probability that, so we've got 514. Now I want you to please note in this case that we were looking in this case for, if I added those two, okay, 514, or they are axis and defective, so that's plus 58. So that would be divided by 600. And so plus 58. Okay, and this is divided by 600. Okay, so I get a probability of 0.95. Okay, or you can say 953. Right, so that's how we're going to get that contingency table. And finally, ladies and gents, I'm just going to do this as one question. Right, so they say to us, or should I do it as one question? No, in fact, let me do it on a different video. All right, let's leave it here, and I'm going to post question 10 as a separate video on its own. I'll see you guys again next time. Sharp, sharp.